The process of formation and evolution of life on Earth. Earth, our planet. Unlike the world we know today, Earth began its life as a terrifying sphere that no movie scene could ever match. What shaped the life and civilization we see now? Based on the modern model of the solar system and the discovery of the oldest rocks on Earth, dating over 4 billion years, 4.03 billion years in Canada, and 4.4 billion years in Western Central Australia, scientists have concluded that Earth formed around 4.7 billion years ago. It came into being through the gravitational aggregation of countless rocks, dust, and gases in a belt of material orbiting the Sun. Initially, Earth was a searingly hot, lifeless planet. Heavy metals gradually sank inward and melted, pushing lighter materials upward as the planet cooled. At that stage, Earth appeared as a massive black sphere with glowing cracks caused by molten material within. These fissures would persist for billions of years and often play a crucial role in the survival of life on the planet. About 4.3 billion years ago, a Mars-sized planet named Theia, which formed during the early solar system, collided with Earth. This catastrophic impact was both a disaster and a crucial precursor to life as we know it. First, it redistributed Earth's materials, creating a more uniform density, similar to shaking a jar filled with different types of candy. Next, it gave rise to the Moon. Material from the surfaces of both planets was ejected into space, forming a ring of debris orbiting Earth, much like Saturn's rings today. Once again, gravity acted as the creator, drawing the fragments together to form the Moon. At that time, the Moon was very close to Earth, and Earth rotated rapidly. If this situation had persisted, life would have struggled to emerge. However, the Moon's presence gradually slowed Earth's rotation through gravitational interactions, while centrifugal force pushed the Moon farther away. This prevented catastrophic tides, potentially dozens of times stronger than the most devastating tsunamis we see today. This was the period around 4.1 billion years ago when oceans and an atmosphere, devoid of oxygen, were forming. From 4.1 to 3.8 billion years ago, the early oceans and the seeds of life. During this period, Earth's surface was dominated by vast oceans, formed as the planet cooled enough to allow liquid water to exist. A relentless bombardment of small asteroids and meteorites, remnants of the early solar system, struck Earth. These celestial objects carried water-bearing minerals and the simplest organic compounds, depositing them into the oceans where life would eventually arise. 3.8 billion years ago. The Archean era, Archean Eon. Earth entered the Archean era, a pivotal stage within the Precambrian period. From the simple organic compounds delivered by meteorites, amino acids began to form in the oceans. These building blocks of life eventually led to the emergence of the first simple cells. Unlike life forms today, these early cells were based on RNA, ribonucleic acid, rather than DNA, deoxyribonucleic acid, the genetic foundation of modern plants and animals. The earliest known fossils, dating back 3.5 billion years, belong to these primitive life forms. Initially, these single-celled organisms formed layers of thick, interconnected colonies called stromatolites. These structures were the first to perform photosynthesis, releasing oxygen into Earth's atmosphere. The first simple glucose molecules, sugars, also began to form during this time. 3 billion years ago, oxygenation of the oceans. By 3 billion years ago, the oceans had become saturated with oxygen. The oxygen reacted with iron in the water, forming iron oxides that sank to the seafloor, creating massive iron ore deposits. These deposits, which are over 3 billion years old, serve as the foundation for much of the modern world's infrastructure. 2.5 billion years ago, the Proterozoic era marked the beginning of significant evolutionary advances in early life forms and the final phase of the Precambrian period. Around 1.2 billion years ago, the first multicellular plants emerged, distinguished by their complex DNA-based structures rather than the RNA-based composition of earlier organisms. 850 million years ago, the global freeze life's progression was abruptly interrupted during Earth's most prolonged and intense global freeze. With oxygen levels in the atmosphere excessively high, the absorption of sunlight diminished, leading to cooling and widespread glaciation. The more ice that formed, the more sunlight was reflected away, as the planet effectively became a giant mirror, incapable of retaining heat. This feedback loop caused Earth to enter a snowball state where the surface was almost entirely frozen. This period lasted over 200 million years. To put this into perspective, humanity, despite its seemingly long history, only developed true civilization and intelligence towards the end of the most recent ice age, approximately 15,000 to 20,000 years ago. In contrast, Earth's global freeze during this period lasted over 200 million years. At that time, Earth was a colossal ice sphere, devoid of life, warmth, or sunlight. Any light from the sun was reflected back into space, leaving the planet in a frigid void. 630 million years ago, volcanic salvation Earth's molten core awakened, becoming the savior of life on the planet. After hundreds of millions of years of dormancy, volcanoes erupted, breaking through the frozen surface. These eruptions released lava and, most importantly, carbon dioxide. While carbon dioxide is a greenhouse gas today, back then it acted as a lifesaver. It trapped solar heat in the atmosphere, gradually melting the ice. This, coupled with the warmth from volcanic activity, allowed Earth's deep ocean life forms to survive and continue evolving. The thawing process spanned several million years, 580 million years ago. The rise of multicellular life. By this time, multicellular plants had become widespread. The period also marked the emergence of the first soft-bodied animals. Fossils from this era have been discovered, revealing the existence of such early creatures. 540 million years ago, the formation of the ozone layer. Oxygen levels in the atmosphere continued to rise, and in the upper layers of the atmosphere, oxygen interacted with sunlight to form ozone. This ozone layer shielded Earth from harmful ultraviolet radiation, setting the stage for life to colonize the land. By this time, the first continents had begun to take shape. 530 million years ago. The Paleozoic era begins. Earth entered the Paleozoic era, starting with the Cambrian period. This era marked an explosion of life, lasting approximately 30 million years, often referred to as the Cambrian explosion. In the oceans, more complex animals appeared, most notably trilobites and their relatives. This period also witnessed the emergence of the first predators, organisms that actively hunted other creatures for food rather than relying on plants or scavenging dead material. For example, the illustration below depicts an anomalocaris, a prehistoric predator, about to attack its prey, a trilobite. 505 million years ago. The Ordovician period. The next stage of plant and animal development began during the second period of the Paleozoic era, the Ordovician period. At this time, oceans covered much of the northern part of Earth, while life flourished on the southern supercontinent, Gondwana. This era saw a significant expansion of mollusks and a remarkable diversification of fish species. The first fish emerged and dominated the oceans throughout this period, the Devonian period. During the Devonian period, a groundbreaking evolutionary step occurred, a type of fish known as tetrapods Begeichthyostega. This period also saw the rise of large insects, including dragonflies and arthropods, resembling modern species but significantly larger. Simultaneously, plants flourished, growing to towering heights of tens of meters, fueled by the high oxygen concentration 360 to 286 million years ago. The Carboniferous period. The Carboniferous period, also called the Coal Age, was characterized by the widespread burial of dead vegetation, which eventually transformed into today's coal deposits. A pivotal evolutionary milestone during this time was the ability of animals to lay eggs on land. Before this period, even semi-terrestrial species like amphibians and early reptiles still relied on water for reproduction, as their eggs required moisture to support the developing embryos. However, during the Carboniferous, reptiles evolved to lay amniotic eggs, self-contained eggs with water and nutrients inside, enabling them. The first reptiles to exhibit this adaptation were Hylonomus and Paleothyrus. From 286 to 248 million years ago, Earth entered the final stage of the Paleozoic era, the Permian period. This period was crucial for the evolution of animals. Certain reptiles began transitioning into early mammals, such as the therapsids. For example, therapsids evolved from creatures like Dimetrodon, developing facial and dental structures similar to modern mammals. Therapsids were among the fearsome predators of the Permian period. Unfortunately, mammals faced significant challenges in their early development. Therapsids, along with many other reptiles, fell victim to the greatest extinction event in Earth's history, the Permian extinction. The Permian-Triassic extinction event. Although the causes of this mass extinction remain debated, a prevailing theory attributes it to the collision of the Laurasia and Gondwana supercontinents, forming the supercontinent Pangaea. This tectonic shift disrupted landscapes, triggering massive earthquakes and volcanic eruptions on a continental scale, devastating terrestrial and marine life. Marine species were hit hardest, with 95% of all oceanic life wiped out. This catastrophe marked the end of the Permian period and the beginning of the Mesozoic era. The Triassic period, the dawn of dinosaurs, 248 million years ago. Following the Permian extinction, conditions stabilized, but the environment had dramatically changed. Some species adapted more successfully than others, evolving to dominate both land and sea. The first period of the Mesozoic era, the Triassic, heralded the age of dinosaurs, a golden age for reptilian evolution. The ancestors of mammals, such as cynodonts, survived and laid the groundwork for the eventual rise of mammals, including humans. However, during the Triassic period, mammals and fish were overshadowed by the dinosaurs. Dinosaurs thrived in diverse habitats and displayed a range of sizes and forms. In the oceans, predators like Ichthyosaurus and Nothosaurus ruled the depths for millions of years. On land, dinosaurs flourished even more, categorized into three main groups: theropods, predatory dinosaurs such as Tyrannosaurus rex, T-Rex, Celophysis, and Allosaurus; sauropods, long-necked dinosaurs, including Apatosaurus and Mamenchosaurus; ornithischians, herbivorous dinosaurs like Triceratops, Stegosaurus, and Iguanodon. Among them, Tyrannosaurus rex emerged as one of the most iconic predators, symbolizing the dominance of dinosaurs during the Triassic period. The Jurassic period and the rise of new life forms, 213 million years ago. The Jurassic period began 213 million years ago, marking the middle phase of the Mesozoic era. Once again, the supercontinent Pangaea began to break apart into Laurasia and Gondwana. The rifting caused widespread destruction of various species, including plants, fish, and marine animals. Meanwhile, on land, reptiles continued to thrive. By the middle of the Jurassic period, they dominated the skies, land, and oceans, with many new species emerging compared to the Triassic period. In the oceans, plesiosaurs appeared, reigning over the seafloor. In the skies, pterosaurs, winged reptiles, ruled, though they were not the ancestors of modern birds. The ancestors of birds themselves began to evolve during the Jurassic period, with a carnivorous dinosaur developing feathers and transitioning into a species that bridged the gap between reptiles and birds. The Archaeopteryx is considered the ancestor of modern birds. Mammals during this period were small creatures, resembling today's rodents. They lived in hiding, avoiding the predation of the dinosaurs. The Cretaceous period and the end of the dinosaurs, marking the final stage of the dinosaur reign and the last period of the Mesozoic era. The most significant development of this period was the appearance of flowering plants, which were pollinated by insects. These plants replaced the older generation of ferns and conifers. The change in vegetation led to a decline in dinosaur prosperity, though they still remained the dominant species until the end of the Cretaceous. The prevailing scientific opinion today supports the hypothesis of an asteroid impact as the primary cause of the mass extinction event that occurred 65 million years ago. Evidence of iridium, a substance that can only be found from extraterrestrial sources, was discovered in Central America, specifically in the Yucatan Peninsula. According to this hypothesis, an asteroid with a diameter of over 10 kilometers collided with Earth, creating the modern-day Gulf of Mexico and triggering the largest tsunami and earthquake in the entire Mesozoic era. More importantly, the impact caused drastic climate changes. Intense volcanic eruptions and asteroid bombardments killed numerous large animal species. The dust and soot from the volcanic activity and impacts covered the sky, blocking sunlight and causing the mass death of plants. The depletion of food supplies and sudden temperature shifts were the key factors that led to the extinction of the dinosaurs. However, in terms of scale, this collision cannot compare to the Permian mass extinction. As a result, some smaller reptiles and birds survived due to their lower food requirements and their ability to easily escape the effects of the disaster. Most importantly, the ancestors of modern mammals managed to survive the catastrophe and enter the next phase of Earth's history. The Cenozoic era, age of mammals. A world without dinosaurs remained empty for a long time, as birds had not yet flourished, and mammals had adapted to hiding in burrows to avoid dinosaurs. It was not until nearly 60 million years ago that mammals emerged to the surface and began evolving into various forms, from predators to prey. A significant threat to them at the time were giant carnivorous birds. Around 55 million years ago, at the end of the Paleocene, a part of the Cenozoic, primates began to appear in tropical and subtropical regions. They had more flexible traits than other species, allowing them to adapt to their environment. Their front feet, later evolving into hands, had 5 digits, with an opposable thumb allowing grasping and branch hopping. Their flexible necks enabled them to observe from various angles. These were the first ancestors of humans. During the Eocene, immediately after the Paleocene, from 55 to 33.7 million years ago, the climate became warmer and tropical forests expanded from the equator, while ice concentrated at the poles, especially Antarctica. During this time, many plants and animals appeared that resembled modern-day species, the most notable being hoofed animals and some primates more closely related to us. A key development during this period was the emergence of 2 groups of hoofed animals, Artiodactyla, ancestors of modern-day deer, and Perissodactyla, ancestors of horses and rhinoceroses. These animals were common during this time. The horses of that era were quite small, no bigger than small dogs today. Over time, they gradually went extinct, leaving only a few survivors that evolved into modern horses, zebras, and rhinoceroses. Another noteworthy and important branch in the history of life development was the Mesozoics, animals resembling hyenas and wolf-like dogs. These were predatory animals over 30 million years ago. Well adapted to aquatic environments, they eventually left land and evolved into the whale species we know today. The true ancestors of humans appeared around 3.7 million years ago, which is the earliest point where we can record the footprints of hominids that were able to walk on 2 legs. This species, named Australopithecus, developed in the forests of Africa. The desertification of the continent turned forests into deserts or grasslands, leaving no trees to climb, and Australopithecus gradually evolved to adapt to life without trees. Australopithecus later evolved into Homo habilis, which resembled modern humans more closely, and further evolved into Homo ergaster, followed by Homo erectus, with less body hair, concentrated mainly on the head, and body functions quite similar to those of modern humans. Homo erectus is believed to be the first human-like ancestor of modern humans, with a brain size about 74% that of modern humans, around 1.8 million years ago. It wasn't until about 100,000 years ago that Homo sapiens, the first fully intelligent human species, truly emerged. They were the most intellectually advanced branch of the hominid genus Homo. As Africa underwent desertification, they crossed the boundaries between Africa and Europe, spreading across Europe and Asia, initially the Middle East, and living alongside strange creatures during the Ice Age, such as mammoths, and other mammals with shapes somewhat different from animals today. As the Ice Age came to an end around 12,000 years ago, humans truly entered their era, forming societies that range from small to large, from simple to complex. While dinosaurs were the longest reigning species on Earth in the planet's history, humans have only dominated for a very short period. But we have developed the fastest in terms of population, societal growth, and scientific progress. And everything we have today, including the words you are reading now, is the result of this entire process. Thank you for watching. If you enjoyed this video, don't forget to like, share, and subscribe to our channel for more fascinating content. Leave your thoughts or questions in the comments below. We'd love to hear from you. See you in the next video.